Welcome to The Explainer. Today, we're going to dig into this one super clever trick that's right at the heart of models like GPT. It's a really cool idea that solves a huge paradox, and honestly, it's what unlocks the power of all modern generative AI.
So let's start with a bit of a puzzle. You've got these huge AI models, right? And they can learn by basically inhaling an entire book all at once. But then, when you ask them to write something, they have to do it just like us, one single word at a time. How can both of those things be true? It seems like a total contradiction, but solving this is the key.
All right, so this puzzle leads us straight to a fundamental challenge, something we can call the generator's dilemma. It's this constant battle between the need for speed during training and the need for logic when it's actually creating something. Now, to generate text that actually makes sense, these models have to be autoregressive. I know, that sounds super technical, but the idea is actually really simple. It just means the next word always depends on all the words that came before it. You can't predict the word mat without knowing the sentence started with "the cat sat on the." It's the only way to write something that's coherent.
So think about it. When you actually ask an AI to write you a story, a process called Inference, by the way, it has absolutely no choice but to work step by step. It generates the first word, then it uses that word to figure out the second, and so on. It can't see into the future, so this is the only logical path forward.
But here's the big question. What about when the model is training? To learn from, basically the entire internet, does it also have to read one word at a time? Because if it does, the training process would be unbelievably, impossibly slow. And that's the dilemma. So this left developers with two just awful options. Option A, you train it sequentially. It's the correct way, but it is so slow it's not even funny. To process a single 300-word paragraph would take 301 separate steps for just one training example. Now imagine trying to do that for billions of pages. Yeah, no way. Option B is to do it in parallel. Process all the words at once. This is super fast, but it has a fatal flaw. The model learns to cheat.
So, let's talk about that cheating problem. In the world of machine learning, this has a name. It's called data leakage. And it's the critical flaw that made the super fast approach seem totally useless. We're going to use a really simple sentence to see what's going on here. Let's say we're training the model on the phrase, "the cat sat on the mat." The whole goal is for the model to learn how to predict the next word, no matter where it is in the sentence. Okay, so if we're training in parallel, the model sees the entire sentence all at once. So when its job is to predict the word sat, given the words the cat, well, it can also see the rest of the sentence on the mat. It can just peek ahead, see the answer, and get it right every single time. It's not actually learning language, it's just learning how to copy from the answer key.
And that right there, that is a textbook case of data leakage. The model learns this little trick that makes it look like a genius during training, but that trick is completely worthless out in the real world. Why? Because when it's writing a story for you, it can't see the future. The answer key is gone.
So you see the problem, right? The developers were totally stuck. They could either build a model that was painfully slow but correct, or one that was super fast but basically useless. Neither of those is a good path forward.
But what if you could have your cake and eat it too? What if there was a way to get all the speed of parallel training, but without the cheating? A way to get the best of both worlds? This is where a truly elegant solution changes the game. And this right here, this is the big aha moment for modern AI. The solution is this incredibly powerful, yet surprisingly simple technique called masked self-attention. The idea is just genius. You let the model process the entire sentence at once for maximum speed, but you programmatically blind it from seeing any future words at each step. So when it's trying to predict sat, it can only see the cat. You force it to learn the same way it'll have to perform in the real world.
Okay, so how on earth does this brilliant trick actually work? It all happens inside the model, using a really simple mathematical operation that has this massive impact.
Okay, so first things first. In a process called self-attention, the model calculates these attention scores between every single word in the sequence. You can just think of this table as a grid that measures how relevant each word is to every other word. So to understand cat, it calculates a score for how much attention it should pay to the, to itself, and to sat.
All right, now here's the magic trick. Before these scores are finalized, the model applies a mask. And look what happens. It adds a value of -infinity to every score that connects a word to a future word. So for the word cat, the score connecting it to sat, which comes later, becomes -infinity.
It's basically putting on a blindfold.
So what happens next? These scores get run through a function called softmax. Don't worry too much about the math. Just think of it as a converter that turns all these scores into percentages that add up to 100%. And what happens when you try to convert negative infinity into a percentage? Well, you get 0. And just like that, the mask has completely erased any influence from all the future words.
And there you have it. The model gets the lightning speed of parallel processing, but it's forced to learn without cheating. It's learning the true patterns of language by perfectly mimicking the exact same constraints it'll face in the real world. The dilemma is solved.
Okay, so let's zoom out. What's the big picture here? Why does this one little technique matter so much that you could argue it's the cornerstone of this whole AI boom we're seeing? Seriously, you can't overstate this. Masking isn't just a minor tweak, it's a foundational pillar. It's what allows for the incredibly fast training that these massive models need. It completely prevents that fatal data leakage problem. It's the core of the decoder-only architecture that powers things like GPT. And it enforces that cause and effect, one-way flow of information that you need for the AI to generate text that actually makes sense. And here's a fun little piece of history. The core mechanism here, attention, which sounds so cool and intuitive, was almost given the much clunkier name RNS search. It's kind of funny, and it just goes to show you that sometimes the most powerful ideas are also the most elegant, even in their name. When you get right down to it, this is a story about how one really elegant solution to a fundamental problem can completely change everything. This simple mask unlocked the speed and the scale needed for the entire field of generative AI to just explode. And it kind of leaves you wondering, right? What other simple, world-changing ideas like this are just hiding in plain sight, waiting to be discovered?